One of the things that's important for us to be able to do is to be able to determine whether our estimates from using the linearization or tangent line equations are over or under estimates. And this all comes down to our concavity. So if I have a function that's concave up, and I have my point of tangency, when I draw a tangent line, that tangent line is always underneath the curve. So all of the points along it, the ones we're using to estimate, are underestimates. Whereas if I draw a function that's concave down with a point of tangency and draw my tangent line, I can see that with my tangent line is always going to be above the curve, therefore giving us overestimates. And again, we're looking at the concavity in the region around this point of tangency, because when we're using the tangent line to estimate, we're actually not at the point of tangency. So a good example of this is here a table problem where we're given a table of x values with associated f values and f prime values. And then we are told an important thing here in our problem stem, that the second derivative, f double prime, is greater than 0 or positive for all of the x's within our domain. So first we're asked to write the equation of a tangent line when x is 1. And since we're dealing with a line, I use point slope form. So I need a point. They tell us that x is 1. Well, when x is 1, I can see that my y value is -4. So my point is at 1, -4. And then for my slope, I can see from when x is 1 that the slope is going to be 5. So I've got y plus 4 is equal to 5 times the quantity x minus 1. Since I can see from the next part of this problem that I'm going to be asked to estimate a function value, I'm going to isolate the y. So y is equal to 5 times the quantity x minus 1 minus 4. So then when I'm going through and I do the next part where I'm asked to estimate f of 1.2, I'm just taking my tangent line equation and I'm replacing x with 1.2. And I'm not required to simplify that, so I could leave it just like that. If you are feeling compelled to simplify that, well, 1.2 times 1 is 0.2, times 5 is 1, minus 4, which is about -3. We're then asked to decide if this approximation of f of 1.2 being equal to -3, if that's an overestimate or an underestimate, and to explain why. Well, since we are told that f double prime is greater than 0, so f double prime being greater than 0 means that f is concave up for that entire interval from -1.5 to +1.5. That means that our estimate, is going to be, if I draw a little example here, there's a concave up, here's my tangent line's under, so my estimate is an underestimate, or using more notation, that -3 is smaller than the actual value of f of 1.2.